Okay, in this lesson, we're going to look at some special solutions or special cases for solving equations. We can, when we solve an equation, have one solution. Okay, so let's look at that one first. So all the equations we've dealt with so far have only had one solution. And so let's look at this equation, a very simple equation, variables on both sides. So I'm going to start by maybe moving the 3r by subtracting it. That should be familiar. We're just doing inverse operations. That leaves me 14 minus 10r. Notice we have the same signs, equals positive 24. Then we would subtract 14 from both sides, so this should just be really familiar. Negative 10r equals 10, and then we divide by negative 10. Just like always, we would get r equals negative 1. We have one solution to this equation. So what you're going to see in a minute, I want us to come back to this, and I want us to look at how is this equation different than the next two we're going to do. Okay, so let's look at infinitely many solutions. Okay, so right now, these equations look different, right? So first thing we would want to do is combine like terms. 3x minus 2x would be 2x. Minus 12 equals 2x minus 12. Okay, so what do you notice there? I hope you notice that these are exactly the same. That's really important. If you realize they were exactly the same at this point, then you could stop and you could answer what the solution is. But let's go a step further. Our next step would be to move our variables to the same side. So minus 2x minus 2x. Well, look what happens here. 2x minus 2x is 0. It cancels out. And all I have left is negative 12. Same thing here, 2x minus 2x cancels out, and I have left negative 12. We have the exact same thing on both sides. Is this true? Is negative 12 equal to negative 12? Yes, it is. And what this means is that I could take any real number and plug it in for x, and it would make the equation true. So when that happens, we can say all real numbers. We could say infinitely many because there are so many solutions we could never list all the solutions. You also can say identity. And so what I want you to notice here is that it's the exact same on each side. And so when I realized right here that it was the exact same, I could have stopped and I could have said infinitely many. Okay, let's look at the next one, no solution. Okay, right now it doesn't look the same, it definitely looks different. So let's go ahead and do some work. Let's combine our like terms. 4x plus 2x is 6x minus 2 equals 6x minus 4. Okay, so let's make some notes about this. You see that we have the same amount of x's on each side. They both have 6x, so that's the same. But our constants aren't the same. So it's a little bit different. My next step would be to subtract 6x from both sides. And look at what happens again. 6x minus 6x is 0, which leaves us with negative 2. 6x minus 6x is 0. Which leaves us with negative 4. And so see, this is a little bit different than our infinitely many. With infinitely many, we ended up with the same number and no variables. But with no solution, we're going to end up with different constants and no variables. Is negative 2 equal to negative 4? No, this is not a true statement. The variables canceled out. We lost all of our variables. And we had a statement that wasn't true. And so when this happens, this means that those sides are really not equal to each other. And so for a case like that, we would say no solution. There is no number that we could plug in for x. Now, I told you I was going to ask you to come back and look at the one solution problem with me. And so how is this different? How is the last equation different than the other two? And I hope what you're noticing is that in a one solution equation, the variable doesn't cancel out. The variable doesn't cancel out. We still have a variable. And so you have to be really careful about that. Okay, so because we still have a variable, then we can still say there's a solution.